So to answer part A, initially host A can attempt to send data at its maximum rate of 120 megabits per second, but the physical link between host A and host B will actually limit the rate to the link's capacity, which is 100 megabits per second. So the effective sending rates of A to B initially is constrained by the link speed, which should make it 100 megabits per second. So to answer part B, since host B can only read data out of its TCP receive buffer at a rate of 50 megabits per second, but the data is arriving at 100 megabits per second, the receiver buffer rate will fill up at a rate of about 50 megabits per second. So we have to subtract 100 megabits per second with 50 megabits per second, because there's 100 megabits per second incoming and 50 being read, which means that we have a 50 megabits per second accumulation rate. To answer part C, when host B's TCP receive buffer becomes full, host B's TCP stack will no longer acknowledge the received packets, or it can also adjust its window size to 0 or a smaller value to indicate that it can't accept more data. And this essentially tells host A to stop or slow down its data transmission until host B is able to process more data and free up buffer space. And to answer part D, TCP flow control will cause host A to adjust its sending rate to host B's 50 megabits per second reading capacity, which will prevent data overflow and ensure a smoother data transfer by matching the sender's rate to the receiver's buffer availability.